Hello everyone, welcome back to our YouTube channel. The topic that we will discuss is on electric flux. The term flux is borrowed from hydrodynamics, and this term implies some kind of flow. So, the electric flux through a surface inside an electric field is the total number of electric lines of force crossing the surface in a direction normal to the surface. So, basically, the electric flux through a surface is denoted by a symbol phi subscript E. But electric flux through a closed surface is denoted by a symbol phi E, like this. So now let us draw an electric field lines of force like this, denoted by symbol E. Suppose this is a surface in such a way that if we select a small element area ds and the direction of this is in this direction, denoted by ds vector, the angle between this ds vector and this electric field, say it is theta. If we make use of this definition, electric flux phi E is equal to En ds. This En is the normal components of electric field lines of force. We have also learned that if we have a vector A like this, and if we want to resolve this vector A into components, say this one is x and this one is y, the components of A along y let us represent by ay, and the components of A along x let us represent by ax. If this is theta, then what is ax in terms of capital A vector? This ax, it is equal to capital A then cos theta. So similarly, in this case, what is this En? Normal components of electric field. En is equal to E cos theta. If we substitute this value of En in this equation, then this d phi E is equal to E cos theta then ds. We have also learned that if we have two vectors, say A and B, the dot product of these two vectors is A dot B equal to mod of A, which is simply A, mod of B, which is simply B, and then cos of theta. So therefore, if we apply this dot product in this equation, we can write d phi E is equal E dot ds. So this is the flux through a small area element ds. So if you want to find the total flux, we have to integrate So d phi E is equal integration of E dot ds. This is a surface integral. Integration of this will get simplify E, and this is equal to S E dot ds. So this is the formula for the electric flux through a surface ds. Now, if the surface is a closed surface, then if the surface is a closed surface, then in such case we can write phi E is equal surface integral close like this, so E dot ds. The SI unit of electric flux is Newton meter square per coulomb. So this is the SI unit. We know that the SI unit of electric field is Newton per coulomb. The SI unit of area is meter square. So therefore, the SI unit of electric flux is Newton meter square per coulomb. So now, let us solve this question. The question is given, if A equal 2I cap plus 4J cap plus 10K cap, that is the electric field, calculate the electric flux through a surface of area. Number 1, 40 units in XY plane. Number 2, 20 units in YZ plane. So solution. Given the electric field E equal 2I plus 4J plus 10K. The first question is, we have to calculate the electric flux through a surface of area 40 units in XY plane. So let phi E be the flux to be calculated. Since it is given that the area is XY plane, so let us draw. This one is X. Suppose this one is Y. This one is Z. So if we draw like this, this one is the area of the XY plane. So in which direction? The area formed by X and Y. So the area of the XY plane, it is in the Z direction. So therefore, what is the surface? S is nothing but equal to 40 K cap. Now, by definition, what is electric flux? It is nothing but E dot S. So this is, instead of E, we will write 2I plus 4J plus 10K dot, instead of S, we will write 40K. So this is equal to what? 2I dot 40K. I dot K is 0. So therefore, 2I dot 40K is 0. Now, 4J dot 40K, this one is also 0. And then K dot K is 1. So 10 into 40 become 400. So what is the unit? It is Newton meter square per coulomb. So that is the flux through a surface of area 40 units in XY plane. Now the second question says, calculate the electric flux through a surface of area 20 units in YZ plane. So now let us calculate the second question. So let us draw. This one is X, this one is Y, and this one is Z. So when we say YZ plane, that's mean this is the one. So where is the direction of the area YZ plane? It is in the direction of X. So in the second question, S is equivalent to 20 I cap. So what is phi E? Phi E is equal to E dot ds, E dot S. So phi E equal E dot S. So phi E equal, instead of E, we will put 2I plus 4J plus 10K. Then dot, instead of S, we will put 20I. So I dot I equal 1, J dot I equal 0, K dot I equal 0. So we will have with 40. What is the unit of the electric flux? The unit is Newton meter square per coulomb. So remember that this E, the unit, let us write here, it is Newton per coulomb. And this 40 units here, let us write in terms of meter square. So here also 20 units mean we will write in SI unit, it is meter square. So now the topic that we will discuss is Gauss law. This law gives the relation between electric field at a point on a closed surface and the net charge enclosed by that surface. So, according to Gauss law, it states that the surface integral of electric field intensity over any closed hypothetical surface in free space is equal to 1 by epsilon naught times the net charge enclosed within the surface. Here, epsilon naught is the absolute permittivity of free space. So suppose the surface is a Gaussian surface and summation from I equal 1 say to n q subscript I is the total charge, enclosed by the Gaussian surface. Then, according to Gauss law, What is the surface integral of electric field lines? Then, according to Gauss law, the surface integral of electric field lines over a closed surface is equal to 1 by epsilon naught times summation of qi. I equal 1 to n. So this is Gauss's law. And this surface integral of E dot ds over a closed surface, it is denoted by phi E. So now, let us solve this problem. The question says, two hollow concentric spheres S1 and S2 enclosing charges 4q and 20q respectively as shown in figure. The first question says, what is the ratio of electric flux through S1 and S2? So solution. Number 1. Let phi E be the electric flux through S1 and phi 2 be the electric flux through S2. If we use Gauss law, phi 1 is the flux through surface S1. What is the total charge enclosed within the surface S1? Total charge is 4q divided by epsilon naught. Next, what is phi 2? Phi 2 is the flux through surface S2. So what is the total charge enclosed within the surface S2? It is 20q plus 4q. So total charge is 24q. So this is divided by epsilon naught. The first question says, what is the ratio of the electric flux through S1 and S2? That's mean phi 1 divided by phi 2. So this is equal 4q divided by epsilon naught. Then divide 24q divided by epsilon naught. Epsilon naught and epsilon naught will get cancelled. Q and Q will get cancelled. So 4 and 24 will get cancelled. So that is 4 into 1, 4 into 6. So this implies that phi 1 ratio phi 2, this one is equal to 1 is to 6. That is the first question. The second question says, how will the electric flux through the sphere S1 change if a medium of dielectric constant is introduced in a space inside S1? Instead of air, so now if a dielectric medium is introduced in a space inside S1, then the flux through the surface will change. By given condition, the dielectric constant, capital K, it is 2. So what is phi 1 dash? So phi 1 dash is equal to 4q divided by capital K epsilon naught. So this implies that phi dash equal 4q. What is K? K is 2 divided by epsilon naught. So this 2 and 4 will get cancelled. So what is phi? 1 dash. This one is equal 2 q divided by epsilon naught. So with this, we will end our lecture, and next lecture we will discuss the application of Gauss law.